Now let's look at the other line, which is the upper dashed line. Upper dashed line. It represents the oxygen evolution reaction. Oxygen revolution reaction. It is oxygen gas combined with proton and electron to form two water molecule. Okay, oxygen gas, 4 proton, 4 electron to form two water molecule, and in the liquid state for water. This is the electrode half cell reaction, and the electrode potential by Mann's equation, similar to before, would be electrode potential would be standard electrode potential minus 0.0592 volt divided by N. Of course, this is still at 25 degrees C times log of product water activity, but because it has a stoichiometry factor of 2, so the water activity has to be raised to the power of 2, divided by, in the denominator, oxygen activity AO2 times proton activity, and the stoichiometric factor of 2, so activity of proton raised to the power of 4. Okay, so this gives us the electrode potential for such half-cell reaction, and from the standard electrode potential table, E0 for oxygen, water, for this half-cell reaction would be 1.229 volt versus SHE. So that gives us a Z0. And N, the number of electrons transferred for this half-cell reaction would be 4 electrons. So N equals 4. And similar as before, if we assume for simplicity 1 atmosphere of oxygen ideal gas, then the activity for O2 would be 1. And for solvent, here we have water activity, but water would be the solvent. And generally, for most cases, we would assume the solvent activity to also be 1. Okay, H2O also be 1. With all this information, now the electrode potential would be E0, 1.229 volt minus 0.0592 volt divided by N, which is 4 times log. The numerator becomes 1 because we said water activity is 1. The denominator AO2 activity for oxygen gas we said is also 1. So we are only left with activity of proton raised to the power of 4. Okay, and if we do the simplification, and the 4 in the denominator here and the 4 in the power, if we move it out of log, they would cancel each other, and this would be what we have. Again, remember the log of 1 over activity of proton would be pH. This would give us the electrode potential equals 1.229 volt minus 0.0592 volt times pH. Of course, this is also against standard hydrogen electrode or versus SHE. This tells us the potential for the oxygen evolution reaction with proton at different pH value, and it has the same slope, same negative slope as the hydrogen evolution reaction, as we mentioned before.